You don't need to focus on this. There is nothing here that you need to remember. You can let the sound drift past you without following it. Nothing important is going to happen. This is just a quiet movement through space. The solar system moves through space in silence, turning slowly around the sun at the center, where light spreads outward in all directions without sound. Everything here moves in the same general direction, following paths that curve gently through emptiness, and the motion is so gradual that it feels almost like stillness. Thesan itself rotates, its surface shifting in slow patterns, and the planets circle at their own pace, some closer and faster, others farther out where the cold deepens and time seems to stretch. Space between these bodies is vast and dark, with distances so large they become difficult to imagine, and yet emptiness itself feels calm, untroubled by the turning of worlds. The darkness is not complete. There is always some faint light from distant stars, and the glow of the sun reaches outward, dimming as it spreads, touching each planet with varying warmth depending on how far that planet drifts from the center. The inner regions are warmer, the outer regions colder, and between them all is the quiet vacuum where nothing resists movement, where everything floats. Mercury moves closest to the sun, exposed to intense light on one side while the other side faces away in Tashido, and its surface is marked by ancient impacts, craters that have remained unchanged for vast stretches of time. The planet turns slowly relative to its orbit, so its days are long and the temperature shifts between extremes, but there is no atmosphere to carry sound or wind. It is a silent world, gray and still, its surface baked and frozen in turn, and it continues along its path without variation, circling the sun in a rhythm that has repeated for billions of years. The craters on Mercury overlap in places, newer impacts creating depressions within older ones, and the surface is saturated with these features, a record of bombardment that occurred early in the solar system's history when debris was more abundant. The largest crater basin is enormous, its floor partially filled with ancient lava that flowed and hardened long ago, and around its rim the ground is fractured and disturbed, thrown up by the violence of the impact. But now everything is still, the surface frozen in time, and the only change comes from the slow accumulation of micrometeorites, tiny particles that drift in from space and settle on the ground, adding imperceptibly to the regolith that covers the bedrock. Venus comes next, wrapped in thick clouds that reflect sunlight and hide the surface below. The atmosphere is dense and heavy, pressing down with a weight that would crush and dissolve, and the clouds themselves are made of substances that drift and swirl in slow currents high above the ground. The surface is hot, hotter than Mercury despite being farther from the sun, and the heat comes from the atmosphere trapping warmth, holding it close in a thick blanket that never clears. The planet rotates slowly backward compared to most others, and the days here are longer than the years, though time itself seems less important when everything is hidden beneath the same unbroken cloud layer. The clouds form layers at different altitudes, each moving at its own speed, and the fastest winds blow in the upper atmosphere, circling the planet in just a few Earth days, though the surface below experiences almost no wind at all, the dense atmosphere barely moving. Lightning flickers occasionally in the clouds, brief discharges of electricity, though there is no rain, the temperature too high for any liquid water to form. The surface itself is relatively young compared to other rocky planets, volcanic plains covering much of the landscape, and there are highlands and lowlands, mountains and valleys, all shaped by volcanic activity and the slow movement of the planet's crust. Lava flows stretch for hundreds of kilometers in places, their surfaces frozen in ripples and folds, and volcanic domes rise in clusters, evidence of eruptions that may have occurred hundreds of millions of years ago, or perhaps more recently, though it is difficult to know with certainty when the surface is perpetually hidden. Earth turns at a moderate pace, wrapped in a thin layer of air that holds moisture and movement, and the surface is varied, covered in water and land that shifts slowly over geological time. The moon circles nearby, always showing the same face, its surface gray and cratered, marked by ancient lava flows that darkened portions of its face long ago. The moon pulls gently on the earth, affecting the oceans, and the two bodies move towed through space, a pair that share a rhythm. From a distance, Earth appears blue and white, cloud patterns drifting across the surface, and the whole system continues in its orbit, one year following another without pause. The oceans cover most of the surface, their depths varying from shallow coastal regions to trenches that descend far below, and the water moves in currents that flow continuously, driven by temperature differences and the rotation of the planet. And these currents carry warmth from the equator toward the poles and bring cold water back toward the tropics. The atmosphere moves as well, air masses shifting and mixing, storms forming and dissipating, clouds gathering and releasing moisture, and the cycle repeats, water evaporating from the surface, rising into the atmosphere, condensing into droplets, and falling again as rain or snow. The land itself changes, though slowly, mountains rising as tectonic plates collide, valleys forming where the crust stretches and breaks, and rivers carving channels through the rock, carrying sediment from high elevations down to the sea where it settles and accumulates. The moon's surface tells a different story, one of ancient impacts and volcanic activity that ended long ago, and the dark regions called Maria are basins that filled with lava when the moon's interior was still warm enough to produce volcanic eruptions, and the lighter regions are highlands, older and more heavily cratered, their surface not renewed by lava flows. The moon has no atmosphere, so there is no wind or weather to erode the surface, and the features remain as they were when they formed, craters sharp and well-defined, the walls steep and the floors flat where lava pooled and hardened. The moon's orbit is slowly spiraling outward, the tidal forces between Earth and moon transferring energy, and the Earth's rotation is gradually slowing, though these changes are imperceptible on human timescales, noticeable only when measured over millennia. Mars sits farther out, smaller and colder, its surface a dusty red that comes from iron in the soil. The atmosphere is thin, barely present, and dust storms can rise and spread across the entire planet, driven by winds that move through the sparse air. The surface is old, marked by vast canyons and ancient riverbeds where water once flowed, though now the planet is dry, its polar caps made of ice and frozen carbon dioxide. Two small moons orbit close to the planet, irregular in shape, likely captured from elsewhere, and they circle quickly, shadows passing over the red dust below. Mars turns at a pace similar to Earth, though its year is longer, and the seasons shift slowly as the planet tilts and circles the sun. The canyons on Mars are among the largest in the solar system, systems of valleys that stretch for thousands of kilometers, their walls rising several kilometers above the floor, and the formation of these features remains partly mysterious, possibly created by tectonic activity, possibly by water erosion, or perhaps a combination of processes. The ancient riverbeds branch and merge like river systems on Earth, channels carved into the surface, tributary valleys feeding into larger channels, and some of these features empty into basins that may once have held lakes or seas, flat plains with layered sediments suggesting the presence of standing water for extended periods. The northern hemisphere of Mars is lower and smoother than the southern hemisphere, a dichotomy that divides the planet into two distinct regions. And this difference may be the result of a massive impact early in the planet's history, or perhaps differences in the way the crust formed and evolved. Volcanic features are prominent on Mars, enormous shield volcanoes rising high above the surrounding plains, their slopes gentle but their heights extreme, taller than any mountain on Earth, built up over millions of years by countless eruptions that added layer upon layer of solidified lava. These volcanoes are now dormant, no longer active, though it is unclear when the last eruptions occurred, and the calderas at their summits are vast, collapsed regions where magma chambers emptied and the surface fell inward. The polar caps grow and shrink with the seasons. Carbon dioxide freezing out of the atmosphere during winter and forming a layer of dry ice over the permanent water ice caps, then sublimating again in summer when sunlight returns to the poles. Anthei's seasonal cycle drives changes in atmospheric pressure, the thin air becoming even thinner in winter when much of it freezes at the poles. Between Mars and Jupiter, there is a region filled with smaller bodies, rocks and fragments that never gather into a single planet, and they drift in their own orbits, sometimes crossing paths, sometimes colliding, though mostly they simply continue in the same general pattern they have followed for ages. This belt of material is not dense. The distances between individual rocks are vast, and a spacecraft could pass through without encountering anything, moving through the emptiness where sunlight is dimmer and the cold is deeper than in the inner regions. The asteroids vary in composition, some rocky made of silicate minerals similar to the rocks found on the inner planets, others containing metal, iron, and nickel mixed together, and still others dark and carbonaceous, rich in carbon and organic compounds, primitive material that has remained relatively unchanged since the solar system formed. The largest asteroids are spherical, their gravity sufficient to pull them into round shapes, though most are irregular, their forms dictated by the way they fractured and collided rather than by gravity, and their surfaces are covered in regolith, fine dust produced by countless micrometeorite impacts over billions of years. Some asteroids are binary systems, two bodies orbiting each other, locked together by their mutual gravity, and they tumble through space as a pair, their separation sometimes only a few kilometers, sometimes much more. The asteroids orbit the Sun in the same direction as the planets, though their orbits are more elliptical and more inclined, and some asteroids have orbits that bring them close to the inner planets, crossing the orbits of Mars or Earth or even Venus, and these near-Earth asteroids are relatively small, fragments that have been perturbed by gravitational interactions with Jupiter or Mars. Their orbits changed enough that they now spend time in thinner solar system. Most asteroids remain in the belt, held there by the gravitational influence of Jupiter, which prevents them from coalescing into a planet, and gaps appear in the belt at certain distances where resonances with Jupiter make orbits unstable, clearing those regions over time. Jupiter dominates the outer system, massive compared to the rocky inner planets, and its presence affects everything nearby. The planet is made mostly of gas, with no solid surface to stand on, and its atmosphere is thick, filled with clouds that form bands of color, stripes that circle the planet in zones where winds blow in opposite directions. The Great Red Spot is a storm that has lasted for centuries, a swirling oval that drifts within the southern hemisphere, though even this enormous feature is just one part of the continuous motion in the atmosphere. Jupiter rotates quickly despite its size, and the days here are short, the clouds racing around the planet in a matter of hours. Dozens of moons orbit the giant planet, some small and irregular, others large enough to be worlds in their own right, and they circle in the same general plane, held by gravity that reaches far out into space. The atmosphere of Jupiter is layered, different compounds condensing at different altitudes, and the visible clouds are ammonia ice crystals, white and bright, forming in the coldest regions of the upper atmosphere. While deeper down there are clouds of ammonium hydrosulfide, and deeper still, water clouds, though these lower layers are not visible from space, hidden beneath the upper cloud decks. The colors in the clouds come from trace compounds, sulfur and phosphorus, and complex organic molecules created by sunlight and lightning. And these compounds mix and react, creating the browns and reds and yellows that give the planet its banded appearance. The winds blow in alternating directions, eastward in some bands, westward in others, and the boundaries between these zones are turbulent, smaller storms forming and merging, eddies spinning off from larger features, and the entire atmosphere is in constant motion. The Great Red Spot is a high-pressure system, an anticyclone where winds circle counterclockwise in the southern hemisphere, and the storm is enormous, large enough to engulf multiple Earths, though it has been shrinking slowly over the past century, its size diminishing for reasons that are not entirely clear. The storm rotates once every 6 days or so, its winds reaching speeds of several hundred kilometers per hour, and the center is relatively calm, though the edges are turbulent, the winds shearing against the surrounding atmosphere. The spot drifts slowly westward relative to the planet's rotation, and it interacts with other storms, sometimes absorbing smaller features, sometimes being perturbed by passing disturbances, but it remains stable, a persistent feature that has existed for at least several centuries, possibly much longer. Io is closest of the large moons, a world covered in volcanoes that erupt continuously, driven by tidal forces from Jupiter's gravity. The surface is yellow and orange and red, stained by sulfur, and the constant eruptions reshape the landscape, burying old craters and creating new plains. There is no water here, only molten rock and sulfur compounds, and the moon remains active, never settling into the stillness that marks so many other bodies in the solar system. Europa circles farther out, its surface covered in ice that hides an ocean beneath, and the ice is cracked and refrozen in complex patterns, lines that crisscross the surface where the crust has shifted and moved. The ocean below is kept liquid by the same tidal forces that heat Io, and the moon remains smooth, its surface young compared to most, constantly renewed by the movement of ice. The volcanic plumes on Io rise high above the surface, some reaching altitudes of several hundred kilometers, and the material ejected includes sulfur dioxide gas and fine particles that arc through the vacuum and fall back to the ground, coating the surface in layers of frost and sulfur deposits. The plumes are visible from spacecraft passing nearby, bright fountains of material erupting from volcanic vents, and some of the material escapes Io's gravity entirely, forming a torus of gas and particles that circles Jupiter along Io's orbit, and this material interacts with Jupiter's magnetosphere, creating auroras and radio emissions. The surface of Io changed noticeably over time, volcanic activity so frequent that the landscape is constantly being resurfaced. An image taken decades apart show new lava flows, new volcanic features, and the disappearance of older landmarks buried beneath fresh deposits. Europa's ice shell floats on the ocean beneath, and the surface shows evidence of this. Regions where the ice has cracked and separated, filled in by darker material from below, and other areas where the ice appears to have been compressed and formed ridges, pressure ridges that run for hundreds of kilometers across the surface. The youngest features are bright and smooth, recent fractures where the ice has broken and refrozen, and the lack of craters suggests that the surface is constantly being renewed, old features erased by the movement and turnover off the ice. The ocean beneath may be in contact with the rocky interior, tidal heating keeping the interior warm. And if this is the case, there may be hydrothermal activity on the ocean floor, vents where warm water rises and minerals precipitate, creating environments that might support life. Though this remains speculation, the ocean inaccessible beneath kilometers of ice. Ganymede is the largest moon in the solar system, bigger even than Mercury, and its surface is a mix of old dark terrain and younger lighter regions where the ice has been disturbed and reformed. Callisto sits farther out, ancient and heavily cratered, its surface unchanged for billions of years, a record of impacts that have accumulated over time. These moons all orbit in the same direction, moving in resonance, their positions relative to each other repeating in patterns that have remained stable since the solar system was young. The dark terrain on Ganymede is heavily cratered, similar to Callisto, and it represents the ancient surface, unchanged for billions of years except for the slow accumulation of impact craters. The lighter terrain is grooved, long parallel ridges and valleys that suggest tectonic activity, the ice crust fracturing and moving, perhaps driven by internal heat or tidal forces, and these grooved regions are younger, with fewer craters, indicating that the surface was reshaped after the heavy bombardment ended. Ganymede has a magnetic field, unique among moons, and this suggests a liquid iron core, still warm enough to generate convection currents that produce the magnetic field. And this, in turn, suggests that the moon is more geologically active internally than its heavily cratered surface might suggest. Beneath the surface, there may be layers of liquid water, ocean sandwiched between layers of ice, kept liquid by the heat from the core and by tidal forces, though the details remain uncertain. Callisto is the most heavily cratered body in the solar system, its surface saturated with impact features, and there is no evidence of geological activity, no grooved terrain or volcanic features, just the ancient surface, battered and dark. The largest feature is Valhalla, a massive impact basin surrounded by concentric rings, fractures in the crust that formed when the impact occurred, radiating outward for hundreds of kilometers, and the basin itself is bright, filled with ice that may have melted and refrozen after the impact. Callisto orbits farther from Jupiter than the other large moons, and it does not participate in the orbital resonance that locks Io, Europa, and Ganymede together, and as a result it experiences less tidal heating, and its interior may be cold and inactive, or at least less active than the interiors of the other moons. Saturn lies beyond Jupiter, another gas giant, smaller but still enormous, and it is surrounded by the most extensive ring system in the solar system. The rings are made of countless particles, mostly ice, ranging in size from tiny grains to chunks several meters across, and they orbit the planet in a flat disk that extends outward, bright and reflective. The rings are thin, only tens of meters thick in most places, though they span hundreds off thousands of kilometers, and they shine in sunlight, casting shadows on the planet's clouds below. Saturn itself is pale yellow, its atmosphere less active than Jupiter's, though bands of clouds still circle the planet, driven by winds that blow steadily through the upper layers. The planet rotates quickly, and the days are short, and the entire system moves through space in a slow orbit that takes many Earth years to complete. The rings are divided into several main sections, gaps and divisions separating regions of different density, and the particles in each region orbit at slightly different speeds, those closer to the planet moving faster, those farther out moving slower. The gaps are maintained by the gravitational influence of small moons that orbit within or near the rings, shepherd moons that clear paths through the particles, their gravity pulling on the ring material and creating empty spaces. The particles collide gently with each other, their orbits gradually spreading, though the rings remain confined to a narrow plane, flattened by the same forces that flatten planetary systems, the particles settling into a disk where collisions are minimized. The rings reflect sunlight brightly, their high albedo making them easily visible even from great distances. They appear different depending on the angle of observation. Edge-on they are nearly invisible, just a thin line. But when tilted they display their full extent, bright arcs that extend far from the planet. The rings cast shadows in Saturn's clouds, dark bands that shift position as the rings orbit and as Saturn moves around the Sun, and the shadows are sharp and well-defined, the particles blocking sunlight completely in places, less completely in others where the rings are more diffuse. The rings may be temporary, relatively young compared to the age of the solar system, perhaps the remnants of a moon that was destroyed by a collision or that drifted too close to Saturn and was torn apart by tidal forces, and eventually the particles will spread and fade, though this process takes millions of years. Saturn has many moons, some orbiting within the rings, others farther out where they shepherd the ring particles and create gaps through their gravitational influence. Titan is the largest, bigger than Mercury, and it is the only moon in the solar system with a thick atmosphere, made mostly of nitrogen with traces of methane that form clouds and rain. The surface is hidden beneath the haze, though radar has revealed lakes of liquid methane and ethane, pooled in depressions, and rivers that carve channels through the icy landscape. The atmosphere is cold, far below freezing by Earth standards, and the surface is dim, receiving only a fraction of the sunlight that reaches the inner planets. Enceladus is smaller, its surface bright and icy, and geysers erupt from cracks near the South Pole, shooting plumes of water ice into space, some of which falls back to the surface, some of which escapes to form a faint ring around Saturn. These geysers suggest a subsurface ocean, warmed by tidal forces, and the moon remains active despite its small size. The methane on Titan exists in all three phases: gas in the atmosphere, liquid on the surface, and solid at higher altitudes where temperatures are coldest. And this creates a cycle similar to the water cycle on Earth, methane evaporating from the lakes, rising into the atmosphere, condensing into clouds, and falling as rain. The rain carves channels in the icy surface, rivers that flow toward the lower regions where the liquid collects in lakes and seas, and these bodies of liquid are permanent, stable over long periods, though they may evaporate and refill with the changing seasons. The surface is varied, plains and dunes and mountains, the dunes formed by winds carrying particles of organic material, dark grains that pile into long linear features oriented with the prevailing wind direction. The atmosphere is thick enough to support weather, clouds forming and moving, storms developing and dissipating, and the atmospheric pressure at the surface is higher than on Earth, dense enough that the atmosphere would feel substantial, though the gravity is lower, making it easier to move and less tiring to walk if one could walk there. The haze in the upper atmosphere is created by sunlight breaking apart methane molecules, the fragments recombining into more complex organic compounds, polymers that grow and aggregate and eventually settle out of the atmosphere, drifting down to coat the surface in a layer of dark material. This process has been ongoing for billions of years, and the surface may be covered in a thick layer of organic sediment, material that on Earth might be considered prebiotic, compounds that could serve as building blocks for life, though on Titan the cold temperatures prevent the kind of chemistry that leads to biology. Enceladus is small, only a few hundred kilometers in diameter, but its geological activity is remarkable, the geysers erupting continuously from the South Polar region, and the heat required to maintain these eruptions comes from tidal forces. The Moon's orbit slightly eccentric, causing it to flex as it moves around Saturn, and this flexing generates heat through friction, warming the interior and maintaining a subsurface ocean. The geysers erupt from long fractures in the ice, tiger stripes that run parallel across the South Polar terrain, and the plumes contain water vapor and ice particles and traces of salts and organic compounds, material from the ocean below. And the composition suggests that the ocean is in contact with a rocky core, minerals leaching into the water, creating an environment that might be habitable. Uranus orbits farther out, tilted on its side so that its poles point toward and away from the Sun as it circles. Anti's unusual orientation means that each pole experiences decades of continuous sunlight followed by decades of darkness. The planet is pale blue-green, its atmosphere containing methane that absorbs red light, and it appears calm from a distance, though winds do blow through the upper layers, and clouds do form, though they are subtle and difficult to see. Uranus has rings, though they are dark and narrow, not as prominent as Saturn's, and the planet has many moons, most of them small and irregular, though a few are larger, their surfaces a mix of ice and rock, marked by canyons and plains and ancient craters. The axial tilt of Uranus is extreme, the planet essentially rolling along its orbit rather than spinning upright like most planets, and this creates unusual seasonal patterns, each pole pointing toward the Sun for half of the planet's 84-year orbit, then pointing away for the other half. During the polar summer, the Sun circles sky near the horizon, never setting, and during the polar winter, the pole remains in darkness, and the equator experiences a more conventional day-night cycle, the Sun rising and setting as the planet rotates. The atmosphere is relatively featureless when observed in visible light, the cloud layers uniform and bland, though observations in other wavelengths reveal more structure, bands and storms that are faint but present, and the winds blow at moderate speeds. Slower than on Neptune but still substantial. The rings of Uranus are narrow and dark, composed of particles that reflect very little light, possibly organic compounds that have been darkened by radiation, and the rings are confined to narrow bands, maintained by shepherd moons that orbit nearby, their gravity keeping the particles from spreading. The rings were discovered relatively recently, noticed when the planet passed in front of a star, and the star's light flickered as the rings blocked, and revealed it in a pattern that indicated the presence of narrow bands of material. The moons of Uranus are diverse, some regular satellites that orbit in the same plane as the rings, others irregular captures that orbit at steep inclinations or in retrograde directions, and the surfaces of the regular moons show a variety of features, icy plains and ridges and scarps, evidence of geological activity in the past. Neptune is the farthest of the large planets, deep blue in color, and its atmosphere is more active than Uranus despite being farther from the Sun. Winds here are the fastest in the solar system, reaching speeds that would tear apart any structure, and dark spots appear and disappear in the clouds, storms that form and dissipate over months or years. The planet is cold, and the sunlight that reaches it is faint, but there is still internal heat that drives the atmospheric motion, energy left over from the planet's formation. Neptune has a large moon called Triton, which orbits backward compared to the planet's rotation, suggesting it was captured from elsewhere. And Triton's surface is icy, marked by geysers that erupt with nitrogen gas, and the temperature here is among the coldest in the solar system, only slightly above absolute zero. The dark spots on Neptune are anticyclones, high-pressure systems similar to Jupiter's Great Red Spot but less permanent, forming and disappearing over timescales of months or years rather than centuries. And when they are present, they are prominent, dark ovals surrounded by bright methane ice clouds that form at high altitudes where the rising air creates condensation. The winds on Neptune are supersonic in places, the fastest measured winds in the solar system, and the cause of these high wind speeds remains partly mysterious, since Neptune receives so little energy from the sun, and the winds must be driven primarily by internal heat, the planet radiating more energy than it receives, heat left over from its formation still leaking out into space. Triton's retrograde orbit indicates that it did not form around Neptune, but was captured, likely from the Kuiper belt, and the capture process would have been violent, disrupting any other moons that Neptune might have had and circularizing Triton's orbit through tidal interactions. The orbit is slowly decaying, Triton spiraling inward, and eventually it will cross the Roche limit, the distance at which tidal forces overcome the moon's gravity, and it will be torn apart, the fragments forming a new ring system around Neptune, though this will not occur for millions of years. The surface of Triton is young, few craters, indicating that the surface has been renewed relatively recently, and the geysers erupt from the south polar region, nitrogen geysers that shoot plumes of gas and dark material several kilometers into the thin atmosphere, and the material falls back to the surface, creating dark streaks that mark the landscape. Beyond Neptune, the solar system continues into a region where sunlight is dim and the distances grow even larger. Small icy bodies orbit here, some in the Kuiper belt, a disk of objects that extends outward from Neptune's orbit, and others in the scattered disk, where orbits are more elongated and tilted. Pluto is one of the Cebades, a dwarf planet with a heart-shaped region on its surface, bright plains of nitrogen ice surrounded by darker terrain, and it has moons of its own, the largest being Charon, which is so large relative to Pluto that Thetwo orbit a common point between them, a binary system that tumbles through space together. The surface of Pluto is varied, with mountains of water ice and plains that appear to have flowed and refrozen, and the atmosphere is thin, freezing and falling to the surface when the planet is farthest from the sun, then sublimating gagging when it approaches closer. The Kuiper belt is populated with thousands of known objects, likely millions more too small or distant to detect, and these bodies are remnants from the formation of the solar system, material that never gathered in top planets, preserved in the cold outer regions where they have remained largely unchanged for billions of years. The objects vary in size, some small, just a few kilometers across, others large enough to be considered dwarf planets, round bodies with their own moons, and their compositions are similar, icy mixtures of water and methane and ammonia and other volatile compounds, frozen solid at the temperatures found in the outer solar system. Pluto's heart-shaped feature is a plain of nitrogen ice, Sputnik Planitia, and the nitrogen appears to have flowed like a glacier, convecting in slow cells driven by heat from below, and the surface is young, with no craters, indicating that the plane is constantly being renewed, old features erased by the slow movement of the ice. Mountains border the plain, mountains made of water ice, which at Pluto's temperatures is as hard as rock. These mountains rise several kilometers above the surrounding terrain, their peaks sharp and steep, and they appear to be floating in the denser nitrogen ice, blocks of water ice that have been pushed up and displaced. Charon's surface is different from Pluto's, darker and more heavily cratered, with large fractures that run across surface, canyons and scarps that suggest the moon's crust has been stretched and broken, possibly by tidal forces early in its history when the orbit was still evolving. Pluto and Charon are tidally locked, always showing same faces to each other, and they orbit a common center of mass that lies in the space between them, both bodies rotating around this point, and from Pluto's surface, Charon would appear to hang motionless in the sky, always in the same position, never rising or setting. Farther out still, there is the Oort cloud, a vast spherical shell of icy bodies that extends halfway to the nearest stars, and these objects are so distant and so cold that they barely move, their orbits taking millions of years to complete. Occasionally, one of these bodies is disturbed, its orbit changing so that it falls inward toward the sun, and as it approaches, the ice begins to sublimate, forming a coma of gas and dust, and if the comet passes close enough, a tail develops pushed outward by the solar wind and radiation pressure, always pointing away from the sun. The comet brightens as it nears the inner solar system, then dims again as it recedes, returning to theckled outer regions or, if its orbit has changed enough, settling into a shorter orbit that brings it back more frequently. The sun continues to shine, fusing hydrogen into helium in its core, and the energy produced takes thousands of years to work its way to the surface, where it is finally released as light and heat that spread outward into space. The sun's surface is not uniform. Darker regions called sunspots appear and fade, places where magnetic fields suppress the convection that brings heat from below, and these spots come and go in cycles that last about 11 years, though the sun has been shining for billions of years and will continue for billions more, its fuel vast and its process steady. The light that leaves the sun travels outward at a constant speed, reaching Mercury in minutes, Earth in about 8 minutes, and Neptune in hours, and even then it continues, growing fainter with distance but never truly stopping, spreading into the space between stars. The solar wind flows outward as well, a stream of charged particles that moves through the solar system, interacting with magnetic fields and atmospheres, creating auroras on planets that have both, and pushing outward until it meets the interstellar medium, the thin gas that fills the space between stars, and there it slows and mixes, forming a boundary called the heliopause, where the sun's influence fades and the environment of interstellar space begins. The heliopause is not a sharp boundary but a transition region, a zone where the solar wind pressure decreases and the pressure from the interstellar medium increases, and the two meet and mix, creating turbulence and fluctuations, and the boundary shifts inward and outward depending on the strength of the solar wind, which varies with the solar cycle, stronger during solar maximum when the sun is more active, weaker during solar minimum. The heliopause marks the edge of the heliosphere, the bubble of space dominated by the sun's influence, and beyond it is interstellar space, where the environment is shaped by other stars, by supernova remnants, by the galactic magnetic field, by the thin gas and dust that permeate the galaxy. Everything here moves together, the sun and planets and moons and smaller bodies, all orbiting the center of the galaxy, which itself is moving through space, part of a larger structure, a group of galaxies that drift together. And this motion continues on scales so large they are difficult to comprehend, everything turning and drifting through the universe in patterns that have persisted since the beginning. The asteroid belt continues its slow orbit, each rock following its own path, some inclined relative to the plane of the planets, others moving in nearly circular orbits, and collisions are rare, though they do happen, fragments breaking off and creating new smaller bodies that drift in their own trajectories. Some of these fragments eventually fall inward, crossing the orbits of the inner planets, and they may impact a moon or planet, adding to the surface, or they may pass by, their orbits altered by the gravitational pull, and they continue on, moving through the solar system until they collide with something or are ejected into interstellar space. The moons of the outer planets continue their orbits, some locked in resonance with each other, their positions replicating in patterns, and this resonance helps stabilize their orbits, preventing close encounters that might disrupt the system. The moons are varied, some icy and smooth, others rocky and cratered, and a few show signs of geological activity, either current or in the past, places where the interior was warm enough to melt and flow, reshaping the surface. Most, though, are cold and still, their interiors frozen, their surfaces unchanged for billions of years except for the slow accumulation of impacts. The rings of Saturn continue to orbit the planet, the particles colliding gently with each other, spreading and clumping, their orbits influenced by the moons that pass nearby, and the rings remain thin and bright, reflecting sunlight, visible from across the solar system with a telescope, though from Saturn itself they would appear as a faint line in the sky, bright where they catch the sun, dark where they pass into shadow. The rings are thought to be temporary, relatively speaking, perhaps the remains of a moon that broke apart or material that never coalesced, and eventually they will spread and fade, though this process takes millions of years, and for now they remain one of the most striking features of the solar system. Space itself is not completely empty. There is a thin distribution of hydrogen atoms, perhaps one per cubic centimeter in the inner solar system, fewer in the outer regions, and this gas is so tenuous that it has almost no effect on anything, though over vast distances it does interact with light, absorbing certain wavelengths, and it is the medium through which the solar wind flows. Dust is also present, tiny particles left behind by comets and asteroids, and these particles drift through the solar system, some of them eventually spiraling into the sun, others colliding with planets or moons, and they scatter sunlight, creating a faint glow called the zodiacal light, visible from Earth under dark skies, a diffuse band that stretches along the plane of the solar system. The planets continue their orbits, each one moving at a speed that depends on its distance from the sun, thinner planets faster, the outer planets slower, and this has always been the case, a consequence of the way gravity works, the way orbits balance the pull inward with the motion forward. The orbits are not perfect circles. They are ellipses, slightly elongated, and the planets move faster when they are closer to the sun and slower when they are farther away, though the differences are subtle for most, more pronounced for some of the smaller bodies with more eccentric orbits. Mercury continues its lonely circuit, baked and frozen, its surface marked by long cliffs called scarps, where the planet's crust has cracked and shifted as the interior cooled and contracted, and these features are old, unchanged for billions of years, and the planet remains airless and silent, its days long, its nights equally long, and the sun appears enormous from its surface, more than twice the size it appears from Earth, and the light is harsh and direct, casting sharp shadows. The scarps on Mercury run for hundreds of kilometers, steep cliffs that cut across the landscape, and they formed as the planet cooled and its interior shrank, the crust fracturing and one side sliding over the other, creating these long linear features. Some scarps are kilometers high, towering walls that would dwarf any cliff in Earth, and they cut through craters and plains alike, indicating that they formed after much of the heavy bombardment had ended. The surface of Mercury is covered in a layer of fine dust, regolith created by the constant rain of micrometeorites, and this dust has accumulated over billions of years, a gray mantle that softens the landscape slightly, filling in small depressions and coating the rocks. Venus rotates slowly beneath its thick clouds, the surface hidden, the heat trapped, and the atmospheric pressure ground level is crushing, the temperature hot enough to melt lead, and the environment is hostile, though the planet continues in its orbit, its path stable, its rotation slow and retrograde, and the clouds above remain unbroken, reflecting sunlight, making the planet bright in Earth's sky, visible in the morning or evening depending on where Venus is in its orbit relative to Earth. The volcanic features on Venus are numerous, thousands of volcanoes scattered across the surface, and some aerosmall cones just a few kilometers across, while others are enormous shield volcanoes that rise several kilometers above the surrounding plains, their slopes gentle, built up by countless eruptions of fluid lava that spread in thin sheets before solidifying. The lava plains are extensive, covering most of the planet, and they are relatively smooth, wrinkled in places where the surface has compressed and folded, creating ridge belts that run for hundreds or thousands of kilometers. Some regions show evidence of more recent volcanic activity, areas where the surface appears fresher, less weathered by the harsh environment. Though without a way to date the surface directly, it remains uncertain when the last eruptions occurred. Earth continues its turn, the seasons shifting as the planet tilts toward and away from the sun, and the moon continues its orbit always showing the same face, its far side forever turned away, and the system remains stable, the moon's gravity pulling on the oceans, causing tides that rise and fall twice each day, and the Earth's rotation is gradually slowing, a tiny amount each century, as energy is transferred to the moon, which drifts slightly farther away, though these changes are slow. Imperceptible on human timescales, noticeable only over millions of years. The atmosphere of Earth is thin, just a narrow layer that clings to the surface, held there by gravity, and extends upward, growing thinner with altitude until it fades into the vacuum of space, though there is no sharp boundary, just a gradual transition. The air moves constantly, driven by differences in temperature and pressure, heat from the sun warming the equator more than the poles, and this creates circulation patterns, air rising at the equator and flowing toward the poles, sinking and returning toward the tropics, and these flows are deflected by the planet's rotation, creating the trade winds and westerlies that move weather systems around the globe. Mars continues its orbit, its surface cold and dry, the thin atmosphere barely present, and the polar caps grow and shrink with the seasons, carbon dioxide freezing out of the air in winter and sublimating in summer, and dust storms rise and spread, the winds carrying fine particles across the surface, depositing them in dunes and drifts, and the landscape remains mostly unchanged. The ancient valleys and canyons and volcanoes all still there, shaped by processes that ended long ago. Though the planet still experiences weather, still has an atmosphere, however thin, and clouds still form, and frost still appears on the ground in the early morning before the sun warms the surface enough to sublimate it away. The two small moons of Mars, Phobos and Deimos, orbit close to the planet, irregular in shape, cratered and dark, and they are thought to be captured asteroids, bodies that once orbited in the asteroid belt but were perturbed by Jupiter's gravity and eventually encountered Mars. Their orbits altered until they were captured by the planet's gravity. Phobos is the larger and closer of the two, orbiting so close that it circles Mars 3 times each Martian day, and its orbit is slowly decaying, the moon spiraling inward, and eventually it will cross the Roche limit and be torn apart, creating a ring around Mars, though this will not happen for several million years. Deimos orbits farther out, its motion slower, and it appears as a bright star in Mars's sky, rising in the east and setting in the west, though it takes more than a Martian day to complete one orbit, so it appears to move slowly across the sky. The asteroid belt drifts in its orbit, the individual bodies too small to reshape themselves into spheres, their gravity too weak to pull them into round forms, and they remain irregular, their surfaces covered in regolith fine dust created by countless small impacts, and they tumble slowly as they orbit, their rotation rates varying, some fast, some slow, and they continue on, unchanged except for the occasional collision that chips away a fragment or, very rarely, breaks a body into pieces. Some asteroids have their own small moons, satellite bodies that orbit them, held by the weak gravity of the parent asteroid, and these binary or multiple systems are relatively common, perhaps formed when a collision broke a larger asteroid into pieces that remained gravitationally bound, or when material was ejected from the surface during a collision and went into orbit rather than escaping entirely. The moons orbit close to their parent bodies, often just a few kilometers away, and they move slowly, their orbital periods measured in hours or days, and they remain in the asteroid belt, part of the collection of material that never became a planet. Jupiter continues to dominate the outer solar system, its gravity affecting everything nearby. Its mass so large that it accounts for most of the planetary mass in the entire system, and its presence has shaped the solar system, clearing gaps in the asteroid belt where its gravitational resonances destabilize orbits, and it may have migrated inward or outward during the early history of the system, its motion affecting the other planets, scattering small bodies, influencing the distribution of material, and it remains now in a stable orbit, its moons circling, its atmosphere churning, the great red spot drifting slowly westward relative to the surrounding clouds, and the planet continues its rapid rotation, the clouds racing around, the band shifting subtly over time, an auroras flicker near the poles, created by charged particles from Io spiraling along magnetic field lines and colliding with the upper atmosphere, producing light that glows in ultraviolet, visible only with specialized instruments. The magnetosphere of Jupiter is enormous, extending millions of kilometers into space, and it is filled with charged particles, electrons and ions trapped in the magnetic field, and these particles spiral along the field lines, bouncing between the poles, and when they collide with the upper atmosphere they create auroras, bright ovals that encircle the magnetic poles, and the auroras are continuous, always present, though they vary in brightness and extent depending on the influx of particles from Io and the solar wind. The magnetosphere rotates with the planet, sweeping around once every 10 hours, and as it rotates it drags the charged particles with it, creating a current system that generates radio emissions, bursts of radio waves that can be detected from Earth. Io continues its orbit, the closest of the large moons, and the volcanic activity continues, driven by the constant flexing caused by Jupiter's gravity and the gravitational influence of Europa and Ganymede, which pull on Io in a rhythm that creates heat in the interior, and this heat drives the eruptions, sending plumes of sulfur dioxide high above the surface, some of it falling back, some of it escaping into space, forming a torus of gas that circles Jupiter along Io's orbit. And the moon's surface remains young, constantly renewed, and the volcanoes continue to erupt, their lava flows spreading across the plains, burying older features, and the moon glows faintly in Thanefred, the heat from its surface radiating into space. The lava on Io is extremely hot, temperatures reaching over 1,000 degrees, hotter than most volcanic eruptions on Earth, and the lava flows quickly, spreading across the surface in thin sheets that solidify rapidly in cold vacuum of space. The volcanic vents are scattered across the surface, concentrated in certain regions where the tidal heating is strongest, and some vents are persistent, erupting continuously for years or decades, while others are episodic, erupting in bursts separated by periods of quiescence. The surface around the vents is coated in sulfur deposits, yellow and orange and red, and these deposits form rings and halos around the vents, bright features that stand out against the darker lava plains. Europa continues its orbit farther out, its icy surface bright and reflective, and the cracks in the ice suggest movement, the crust breaking and refreezing, and beneath the ice there is water, kept liquid by the same tidal heating that warms Io, though to a lesser degree, and the ocean is thought to be deep, perhaps tens of kilometers, and the ice above is perhaps tens of kilometers thick, and the moon remains smooth, its surface young with few craters, and the cracks form patterns, lines that cross and recross. Dark streaks where material from below has been brought to the surface, and the moon continues its orbit, locked in resonance with Io and Ganymede, their positions repeating every few days. The linei on Europa are long fractures in the ice, some extending for hundreds of kilometers, and they appear dark because they are filled with material that has welled up from below, possibly salts or minerals or organic compounds that darken when exposed to radiation from Jupiter's magnetosphere. The fractures form complex patterns, some parallel, others crossing at angles, and the patterns suggest that the ice crust has been pulled apart and rotated, possibly by the movement of ice plates floating on the subsurface ocean, similar to tectonic plates in Earth but driven by different forces, perhaps tidal flexing or convection in the ice. Ganymede continues farther out, its surface a mix of old and new, dark terrain covered in craters, bright tearing with grooves and ridges where the surface has been fractured and reformed, and the moon has its own magnetic field, the only moon in the solar system with one, generated by a liquid iron core, and beneath the surface there may be oceans as well, layers of ice and water alternating, though the details remain uncertain, and the moon continues its orbit, the largest moon in the solar system. Larger than Mercury, though less massive, its composition a mix of rock and ice. The grooved terrain on Ganymede is striking, parallel ridges and valleys that run for hundreds of kilometers, and the origin of these grooves remains somewhat mysterious, possibly formed by tectonic extension where crust was pulled apart, or possibly by cryovolcanic activity where liquid water or slush erupted onto the surface and froze, creating ridges. The grooves are relatively young, with few craters, indicating that the surface was reshaped after the heavy bombardment ended, and the presence of grooved terrain suggests that Ganymede was geologically active in the past, its interior warm enough to drive surface deformation. Callisto continues its orbit at the outer edge of the large moons, ancient and heavily cratered, its surface a record of impacts that have accumulated over billions of years, and there are no signs of recent geological activity, gnaw grooves or bright terrain, just the old dark surface, marked by the largest multi-ring impact structure in the solar system, a feature called Valhalla, where an ancient impact created concentric rings that extend outward 400s of kilometers. And the moon remains unchanged, its orbit stable, its surface frozen. The rings around Valhalla are subtle, ripples in the ice crust that formed when the impact sent shock waves through the subsurface, fracturing the ice and creating these concentric patterns, and the rings are spaced regularly, each one marking a zone where the shock wave caused the ice to buckle or crack. The impact must have been enormous, a large asteroid or comet striking Callisto with tremendous force, and the energy released would have melted the ice temporarily, creating a brief period of geological activity before the surface refroze and returned to its current state. Saturn continues its orbit, its rings bright, the particles colliding and spreading, and the planet rotates beneath, its atmosphere banded. The clouds moving in steady streams, and the planet's magnetosphere extends outward, interacting with the rings and moons, and the entire system drifts through space, completing one orbit around the Sun every 29 Earth years. And the rings remain, their particles icy and reflective, and the moons continue their orbits, some within the rings, others farther out. And the system remains stable, the orbits replicating, the patterns continuing. The shepherd moons near Saturn's rings are small, irregular bodies just tens of kilometers across, and they orbit within or just outside the rings, their gravity creating waves and gaps in the ring particles. And some of the simoons orbit in pairs, co-orbital moons that share nearly the same orbit, approaching each other periodically and exchanging orbital energy, swapping positions in a gravitational dance that repeats every few years. The rings themselves are composed of countless individual particles, each one orbiting Saturn independently, and the particles range in size from dust grains to house-sized chunks of ice, and they collide gently, their velocities nearly matching, and the collisions cause the particles to spread slowly outward, though the shepherd moons confine them, preventing the rings from dispersing entirely. Titan continues its orbit around Saturn, its thick atmosphere hiding the surface, and the methane cycle continues, clouds forming and rain falling, liquid pooling in lakes and seas, and rivers carving channels through icy landscape. And the surface is cold, far below freezing, and the atmosphere is hazy, layers of smog created by sunlight breaking apart methane and creating complex organic molecules that drift down to the surface, coating the landscape in a dark layer. And the moon continues its orbit, its day and night cycle slow, tacking 16 Earth days to complete, and the surface receives little sunlight, filtered through the haze, and the environment is dim and cold. But the presence of liquid, the presence of an active cycle, makes Titan unique. The lakes on Titan are concentrated near the poles, particularly the North Pole, where several large seas have been mapped, liquid bodies that span hundreds of kilometers, and the shorelines are irregular, inlets and bays suggesting that the liquid level varies, possibly with the seasons as methane evaporates and condenses. The largest sea is Kraken Mare, a body of liquid methane and ethane that covers hundreds of thousands of square kilometers, and it appears dark in radar images, the smooth liquid surface reflecting radar waves away from the spacecraft. The liquid is cold, temperatures around -180 degrees Celsius, and the composition is primarily methane with dissolved ethane and nitrogen, and the liquid is less dense than water, and the seas are thought to be relatively deep, possibly hundreds of meters in places. Enceladus continues its orbit, smaller than Titan, its surface bright and icy, and the geysers continue to erupt from the South Polar region, shooting plumes of water ice into space. And some of this material falls back, coating the surface, keeping it bright and young, and some escapes, forming a faint ring around Saturn, the ring which extends along Enceladus's orbit, and the geysers suggest a subsurface ocean, warmed by tidal forces, and the moon remains active, its interior warm, its surface constantly renewed, and the plumes continue, visible from spacecraft that have passed nearby, the ice particles reflecting sunlight, bright against the darkness off space. The tiger stripes on Enceladus are long fractures in the ice, running parallel across the South Polar region. Anthe are warmer than the surrounding terrain, heat radiating from the cracks, and this warmth keeps the ice from freezing solid, allowing the geysers to erupt. The fractures are thought to reach down to the subsurface ocean, and tidal forces open and close the cracks slightly, pumping water from the ocean up through the fractures and out into space. And the ice particles in the plumes are tiny, micrometers in size, and they are ejected at speeds off hundreds of meters per second, fast enough to escape Enceladus's weak gravity and enter orbit around Saturn. Uranus continues its orbit, tilted on its side, its poles pointing toward and away from the Sun, and the planet rotates in the opposite direction from most others, retrograde like Venus, though the cause of this unusual orientation is unknown, perhaps a collision early in the solar system's history. And the planet's atmosphere is calm, the clouds subtle, and the color is pale blue-green, and the magnetosphere is tilted as well, not aligned with the rotation axis, creating a complex field that wobbles as the planet rotates, and the rings are dark and narrow, and the moons orbit in the same plane as the rings, their surfaces a mix of ice and rock, cratered and fractured, and the system continues its slow orbit, 84 Earth years to complete one circuit around Thesan. The moons of Uranus are named after characters from Shakespeare and Alexander Pope, and the largest five are Miranda, Ariel, Umbriel, Titania, and Oberon, each one a world of ice and rock, and their surfaces show evidence of past geological activity, though most are now frozen and inactive. Miranda is the smallest of the large moons, and its surface is among the most geologically diverse in the solar system, a patchwork of different terrains, old cratered regions next to younger grooved regions, and enormous cliffs that tower several kilometers high. And the moon appears to have been fractured and reassembled, possibly disrupted by a collision, and then pulled back together by its own gravity. Neptune continues its orbit farther out, the last of the large planets, and the atmosphere is active, winds blowing at high speeds, and dark spots appear and fade, storms that last for months or years, and the planet is deep blue, darker than Uranus, and the magnetosphere is also tilted, creating a field that varies as the planet rotates, and the planet has rings, though they are faint and difficult to see. And the moons orbit in various planes, some regular, some irregular. And Triton is the largest, orbiting backward, its surface icy and marked by geysers, and the moon is slowly spiraling inward, its orbit decaying, and eventually, millions of years from now, it will cross the Roche limit and be torn apart by Neptune's gravity, creating a new ring system. Though for now it continues its orbit, cold and distant, its surface reflecting little sunlight, the temperature among the coldest in the solar system. The surface of Triton is varied, regions of different ages and compositions, and the most striking feature is the cantaloupe terrain, a landscape of pits and mounds that gives the surface a texture resembling the skin of a melon. And the origin of this terrain is uncertain, possibly related to the way ice sublimated and redeposited, creating these irregular features. The geysers on Triton erupt from the South Polar region. Nitrogen geysers thatchute dark material into the thin atmosphere, and the material is carried by winds and deposited downwind, creating dark streaks that extend across the icy surface. And these streaks are visible in images taken by spacecraft, evidence of ongoing geological activity even at these extreme temperatures. The Kuiper belt continues beyond Neptune, a disk of icy bodies, some small, some large enough to be considered dwarf planets, and they orbit the Sun in a region that extends outward, and these bodies are primitive, remnants from the early solar system, material that never gathered into a planet, and they remain frozen, their surfaces barely altered since they formed, and they drift in their orbits, some in resonance with Neptune, others in the scattered disk where orbits are more eccentric. And occasionally one is disturbed, its orbit changing, sending it inward toward the Sun, where it may become a comet, its ice sublimating as it approaches, creating a coma and tail. The bodies in the Kuiper belt are diverse, some reddish in color, possibly due to organic compounds on their surfaces, others white or gray, covered in water ice, and some have their own moons, small satellites that orbit them, held by weak gravity. The largest known Kuiper belt objects include Eris, Makemake, and Haumea, each on a dwarf planet with its own characteristics. And Eris is slightly smaller than Pluto but more massive, its surface bright and reflective, covered in methane ice that sublimates and refreezes as the body moves through its orbit. Makemake is also covered in methane ice, its surface bright, and it has a small moon, discovered relatively recently, orbiting at a distance. Haumea is unusual, elongated in shape, rapidly rotating, completing on rotation in just a few hours, and this rapid spin has stretched the body into an ellipsoid, and Haumea has its own ring system, a thin band of particles orbiting the equator, and it also has two small moons. Pluto continues its orbit, its path eccentric, bringing it closer to the Sun at perihelion, inside Neptune's orbit, then farther out at aphelion, and the orbit takes 248 Earth years to complete, and the planet's surface changes with distance, the atmosphere freezing and falling to the ground when Pluto is far from the Sun, then sublimating again when it approaches, and the surface is varied. The heart-shaped region bright with nitrogen ice, surrounded by darker terrain, and mountains of water ice rise near the edges, and plains appear Tohave flowed, nitrogen ice moving like glaciers, and the surface is young in some places, old in others, and Charon orbits nearby, the two locked in a mutual tide, always facing each other, and they continue together, a binary system, tumbling through space. The mountains on Pluto rise several kilometers above the surrounding plains, blocks of water ice that at Pluto's temperatures are as strong as rock, and the mountains appear to be floating in the denser nitrogen ice of Sputnik Planitia, displaced by the convection of the ice below, and the peaks are sharp and steep, carved by processes that are not entirely understood, possibly sublimation and refreezing, or possibly tectonic forces related to the movement of the nitrogen ice. The plains themselves show patterns, polygonal cells tens of kilometers across, and these cells are thought to be convection cells, regions where warmer ice rises from below and cooler ice sinks, creating slow circulation that renews the surface and prevents craters from accumulating. Charon's surface is different from Pluto's, darker and more heavily cratered, with large fractures that run across surface, canyons and scarps that suggest the moon's crust has been stretched and broken, possibly by tidal forces early in its history when the orbit was still evolving. Pluto and Charon are tidally locked, always showing the same faces to each other, and they orbit a common center of mass that lies in the space between them, both bodies rotating around this point, and from Pluto's surface, Charon would appear to hang motionless in the sky, always in the same position, never rising or setting, and from Charon, Pluto would do the same. The two lock it in a permanent dance. Farther out still, there is the Oort cloud, a vast spherical shell of icy bodies that extends halfway to the nearest stars, and these objects are so distant and so cold that they barely move, their orbits taking millions of years to complete. Occasionally, one of these bodies is disturbed, its orbit changing so that it falls inward toward the sun, and as it approaches, the ice begins to sublimate, forming a coma of gas and dust. And if the comet passes close enough, a tail develops, pushed outward by the solar wind and radiation pressure, always pointing away from the sun. The comet brightens as it nears the inner solar system, then dims again as it recedes, returning to theckled outer regions or, if its orbit has changed enough, settling into a shorter orbit that brings it back more frequently. The comets that come from the Oort cloud are unpredictable, appearing from any direction, their orbits highly elongated, and they spend most of their time in the cold outer reaches, moving slowly, barely influenced by the sun's gravity. And then they fall inward, accelerating as they approach, and they pass through the inner solar system quickly, their speed increasing as they near the sun, and they swing around the sun and head back out, climbing away into the darkness. Some comets are perturbed by the gravity of the planets as they pass through, their orbits altered, and they may be thrown out of the solar system entirely, becoming interstellar objects, or their orbits may be shortened, bringing them back on more frequent visits. The sun continues to shine, fusing hydrogen into helium in its core, and the energy produced takes thousands of years to work its way to the surface, where it is finally released as light and heat that spread outward into space. The sun's surface is not uniform. Darker regions called sunspots appear and fade, places where magnetic fields suppress the convection that brings heat from below, and these spots come and go in cycles that last about 11 years, though the sun has been shining for billions of years and will continue for billions more, its fuel vast and its process steady. The light that leaves the sun travels outward at a constant speed, reaching Mercury in minutes, Earth in about 8 minutes, and Neptune in hours, and even then it continues, growing fainter with distance but never truly stopping, spreading into the space between stars. The solar wind flows outward as well, a stream of charged particles that moves through the solar system, interacting with magnetic fields and atmospheres, creating auroras on planets that have both, and pushing outward until it meets the interstellar medium, the thin gas that fills the space between stars, and there it slows and mixes, forming a boundary called the heliopause, where the sun's influence fades and the environment of interstellar space begins, and everything continues. The sun and planets and moons drifting through the galaxy, part of a system that has existed for billions of years and will continue for billions more, turning slowly through darkness, quiet and untroubled, moving through space without end.